Hi, this is Mrs. Basin, and today we're going to review the notes for stoichiometry. So when you took the notes last night, you learned, and we talked a little bit about this yesterday, stoichiometry is that process of using the chemical equation to look at relative masses of reactants and products in a reaction. So if you know the amount of one substance you have, you can figure out the relative amount of the other substance. So a balanced chemical equation is like a recipe for how those reactants to combine to form products, and that's where we get those ratios that show how the different substances combine or how much of one substance is needed to produce or react with another substance. Finally, we talked about how the coefficients in the equation show the molar relationship between the reactants and products. So those coefficients show what is called the mole ratio, and that's what we use when we're converting from one substance in an equation to another substance in an equation or a reaction. So this was our roadmap that we talked about. So to get from moles of one substance to moles of another substance is where we use that mole ratio. So if we're going from moles of one thing to moles of something else, we use the mole ratio from the chemical equation. So those are those coefficients, those big numbers in front of the reactants and products. That's how you get from one substance to another. If you're going from grams of one thing to moles of one thing, or moles of one thing to grams of one thing, we know that 1 mole equals the molar mass from the periodic table. And that's just like the molar mass that we've done before. Over here, same thing, 1 mole equals the molar mass from the periodic table. So the only time you'll have a number other than 1 in front of moles is when you're using that mole ratio. So in the notes that you did last night, we went in order. So we started with problems that went from moles of one thing to moles of something else. Then we went from moles of one thing to grams of something else. Then we went from grams of one thing to moles of something else. Then we went from grams to grams. So we kind of split those up into the 4 different types of problems you'll have to solve. When you do your work today, that's how they're divided up in there as well. So you'll start with the easiest, which are the moles of one to moles of something else. Then you'll do some grams to moles or moles to grams. And then finally, you'll do grams of one thing to grams of something else. So they're clearly labeled and sectioned out in your packet that you're going to work on today, since this is the first time we've worked through this since we've done the notes. So you're going to start with that. And then tomorrow when we come back, we'll do some of them mixed up a little bit. Now, to kind of model that a little bit in the notes, in this notes review, the 4 practice problems that we're going to do are not in those orders. So these are a couple of the different types, but we're going to kind of identify that type first so you can see how this will work when they're not all sectioned out like they are in the practice today. So again, what we have to start with is the balanced equation. So for these couple problems that we're going to work through now, the balanced equation is given. So we want to know what mass of carbon dioxide is produced when 3.4 moles of propane react. So again, in this reaction, I'm going to go ahead and underline the 2 things that I'm worried about. So we're only going to deal with 2 things at a time in a problem. And then the other thing I'm going to look at is on my map down here, I'm going to mark what I'm starting with and where I'm going, so I know how many steps I'm going to need here. So I'm starting with moles. So I'm starting here, and I'm ending up with grams of something else. So I'm starting with moles of C3H8, and I'm ending with grams of CO2. So C3H8 is my A, CO2 is my B. So just like always, I'm going to start this problem with what's given in the reaction or in the description. So 3.4 moles of C3H8, and then I'm getting to grams of CO2. So my first step down here is to go from moles of A to moles of B. So to do that, I'm using the mole ratio from the chemical equation. So the relationship between propane and CO2 is 3:1. So 3 moles CO2 for every 1 mole C3H8. So again, moles of C3H8 goes on the bottom, so it cancels. Now I'm in moles of CO2. So now I need to go from moles of CO2 to grams of CO2, so I'm going to use the molar mass. So molar mass is grams of CO2 which is 44.01 grams. And then on the other side, anytime I have grams on the other side of that is going to be 1 mole of whatever that substance is. And again, to get this 44.01, all I did was I took 1 carbon, 2 oxygen. So 1 carbon was 12.01, 2 oxygen at 16 each. So this was 12.01, 32. So that's where I got that 44.01. That's just a molar mass. So then that gets rid of moles of CO2. I'm left with grams. That's what it's asking me to find. So just like what we did before, multiply across, divide top to bottom, and I get 449 grams of CO2. And like we talked about, we're going to round to sig figs again. So there's 2 sig figs. You always look at that first number for sig figs, 2 sig figs. So I'm going to round this to 450 grams of CO2. So that's our first example here. Okay, our next example says calculate the mass of propane. So I'm starting with this one, needed to form 95 grams of CO2. So again, I'm still dealing with propane and CO2, but this time I'm given grams and I'm asked to find grams. So I'm starting with grams and I'm going all the way to grams on the other side. So these are the most complicated problems you'll have to do. Grams of one thing to grams of the other. So again, start with what's given, 95 grams of CO2. To get from grams to moles, I'm using a molar mass. So 1 mole of CO2 goes on the top because grams has to be on the bottom because that's what I want to cancel. And from that previous problem, we know molar mass of CO2 is 44.01 grams. Now to get from moles of one to moles of another, using the mole ratio, CO2 goes on the bottom. So this is where this comes from. Coefficients, 3 moles CO2 to 1 mole C3H8. Last step, molar mass. This time, molar mass of C3H8. So just to check here, we've got grams of CO2 is gone, moles of CO2 is gone. Now I want moles of C3H8 on the bottom and grams on the top. And anytime, like we said, you have grams, that's always 1 mole on the other side of it. So I'm going to add up 3 C's plus 8 H's, and that gives me 44.11, which is just a coincidence that it's that close to the other mass. Again, multiply across, divide top to bottom, and I end up with 31.7 grams C3H8. Okay, next one. Now I want to know how many moles of oxygen, so this is my first substance, are needed to react with 2.5 moles of propane. So starting with moles, ending with moles. So this is just a single step problem here. So I'm going to start with 2.5 moles C3H8. I'm going to use a mole ratio to get from moles of one to moles of something else. So again, the ratio is my coefficients. C3H8 goes on the bottom. So 1 mole, that comes from there again, C3H8, to 5 moles of O2. Moles of C3H8 cancels. Multiply across, divide top to bottom, and I get 13 moles of O2. Again, rounding to sig figs. So 2 sig figs here, 2 sig figs in my answer. Okay, last example problem. So now it says what mass of carbon dioxide is produced when 65.5 grams of propane, C3H8, reacts with sufficient oxygen. So anytime you see sufficient or excess, that means we don't need to worry about that. All we care about are those 2 things that it talks about. The one that it gives us an amount for, the other thing that it's asking for an amount for. So any other thing they mention, you don't need to worry about. Okay, so this one, starting with grams, ending with grams. So this is one of those, again, that goes all the way across. So start with what's given. So first step, using a molar mass. So 1 mole C3H8 We have that molar mass, 44.11 grams C3H8 on the bottom. So grams is gone. Now we're going from moles of A to moles of B, so moles of propane to moles of CO2. So we're going to use the mole ratio. So again, 1 to 3. C3H8 goes on the bottom because that's what we're trying to get rid of. So moles of C3H8 is gone. And then now we're going from moles of B to grams of B. So now we need another molar mass. So 1 mole CO2, 44.01 grams CO2. So again, we're just using those molar masses that we calculated in the previous problems. And again, anytime you have grams on one side, it's always 1 mole on the other. The only time you're going to see different numbers in front of moles is when you're doing those mole ratios. Okay, so then once we get to this point, again, multiply across, divide top to bottom, and we're going to round to 3 sig figs, so we get 196 grams of CO2. Okay, so you should start to see a pattern here, especially like with these big ones. Sometimes people think these are the easiest because it's always going grams, moles, moles, grams. You always have grams on the bottom in the first step, grams on the top in the last step. So practice is key to understanding how to do these and also looking for those patterns. They are very systematic. So it's always going to follow that pattern for a given type of problem, but you're always going to start with figuring out how many steps do I need? Where am I starting? Where am I ending up? So that's why this pathway in the beginning until you get the hang of this is going to be really important. So again, you're going to work on some practice. They are split out into the different types for today. That should help a little bit. And then tomorrow we'll kind of start mixing them together. So if you have any questions or want to go over anything or need help with anything, please send me a message and I can Zoom with you so that we can get things cleared up so that we can move forward with this.